surface we know is perpendicular to the normal, right? Everybody got that? Well, what's perpendicular to the horizontal surface? The y-axis. So this angle right here is 55. Could I have also said this? This is 55? Yes. So the angle between two lines is the same angle between two lines that are perpendicular to it.
Could you repeat that last thing? One
Yes.
more time?
So the angle between two lines is the same angle between two lines that are perpendicular to those first two lines. So where do I draw this then? So I have the normal here. So if it's perpendicular to this and this is perpendicular to x, y, it's got to be here. So can't you say that the angle given on the inclined plane is always the angle between the normal and the vertical axis? Who's in?
Do you have to draw the normal force like that, or can you draw it where the n is on the
Sure,
origin?
if you want, you could draw it up like this instead.
Okay.
One or the other, not both, because then it looks like
Right.
there's two ends.
Yeah. Okay.
Okay, so what did we do? This is the beginning of the statics problems, right? Step setup. We looked at the picture, we read the words. This is a scrap. We know it's a 2D problem. We read the words to figure out what was given, what information is given that's not in the picture. And then we read the words to find out what they want to find. Then we made a table. We listed all the forces and what their magnitudes and directions are to determine how many unknowns we have. Because there were two unknowns, we needed two equations. Because there are two equations, we knew we need to analyze one body. We chose the cylinder and we drew the free body diagram of the cylinder. So we've done all steps from 1 to 7. The only thing we haven't done now is find the components of each of the forces and then solve the equations. And we're not going to do that because we're going to do a lot of setups today. So we're moving on to the next problem. Okay, now we're looking at this one. So let's take a look at the picture first. So we have a body here, A. We have a 500 Newton force that's being supplied to this cable system. There are links at 1 and 2. There are some angles given. So let's read the words. The cable is shown, the cable system shown in the figure is being used to lift body A. The cable system's in equilibrium at the cable position, shown in the figure. When a 500 Newton force is applied at joint 1, determine that the words really didn't tell me anything that I don't see in the picture. So I'm just going to write given sketch. Fine. Determine the tension in cable A, B, C, and D. So what do you want to call those? How about T sub A, T sub B, T sub C, T sub D? You could choose whatever variables you want. I mean, we already said that a standard is capital T for tension, right? So then put sub A, B, C, and D. And then whatever variable you intend to use at the beginning, you have to make sure you use that variable going throughout. Okay.
One thing to find mass of body.
Oh, something else? Oh yeah, mass of body A, so I guess we gotta put M because they want mass. Thank you. Okay, so now let's make our table. Force, magnitude, direction. Okay, and then why don't you work with the person next to you, filling out this table. What forces are present? Do you know the magnitudes or no? Put a check mark or a question mark. Do you know the direction? Check mark for yes, question mark for no.
So we have locked it.